Welcome to a journey through the most mind-bending theories about the universe. We often think of the universe as this vast, empty expanse, dotted with stars and galaxies. But what if I told you that our understanding of the cosmos is just the tip of the iceberg? Fasten your seatbelts and get ready to explore the fringes of theoretical physics. Have you ever wondered what would have happened if you'd taken that different path, made a different choice? What if I told you that somewhere in an entirely separate reality you did? That's the essence of the multiverse theory. Imagine, if you will, an infinite number of universes all coexisting alongside our own, each universe a unique variation of the one we inhabit, branching off with every quantum event, every possibility that could have been. In this grand cosmic tapestry, there could be a universe where you're a celebrated musician, another where you're a renowned scientist, and yet another where you never even existed. Scientist as scientist. The implications of the multiverse are staggering. It suggests that our reality, the one we hold so dear, is just a single page in an infinitely long book, a single note in a symphony of existence. But how could such a thing be possible? Some physicists believe that the seeds of the multiverse were sown in the very first moments of the Big Bang. Imagine a rapid expansion faster than the speed of light, tearing apart the fabric of space-time and creating countless bubble universes. Others propose that the multiverse arises from the strange world of quantum mechanics, where particles exist in a superposition of states simultaneously occupying multiple realities. Each time a measurement is made, a new reality branches off, creating a constantly diverging web of universes. The multiverse, as it stands, is still a theoretical concept, albeit a tantalizing one. However, there are those who believe that we might be able to glimpse the echoes of these other universes in the cosmic microwave background radiation, the faint afterglow of the Big Bang. Imagine faint ripples in the fabric of space-time, whispers from other realities. The multiverse theory offers a profoundly humbling and awe-inspiring perspective on our place in the cosmos. What if everything we perceive as real? The world around us, the stars in the sky, even our own thoughts and feelings were nothing more than lines of code in a highly advanced computer simulation. This is the central question posed by the simulation hypothesis, philosopher as philosopher. It suggests that our reality is not what it seems, that we might be living in a digital realm, unwitting participants in a grand cosmic experiment. Think about the exponential growth of computing power we've witnessed in recent decades. Video games, for example, have evolved from pixelated sprites to immersive virtual worlds that are almost indistinguishable from reality. Now imagine a civilization millions of years ahead of our own, with technology beyond our wildest dreams. Wouldn't it be possible for them to create simulations so realistic that the simulated beings within them would be completely unaware of their true nature? Proponents of the simulation hypothesis point to several intriguing clues that might support this idea. For instance, the laws of physics, which govern everything from the smallest atom to the largest galaxy, often appear eerily similar to the rules of a computer program. Furthermore, the universe appears to be finely tuned for life, with fundamental constants perfectly calibrated to allow for the existence of stars, planets, and ultimately us, philosopher as philosopher. Of course, the simulation hypothesis is not without its critics. Some argue that it's impossible to prove or disprove, making it more of a philosophical thought experiment than a testable scientific theory. Despite these criticisms, the simulation hypothesis remains a captivating idea, forcing us to confront fundamental questions about the nature of reality, consciousness, and our place in the grand scheme of things.
Prepare to have your mind truly bent as we delve into the bizarre realm of the holographic principle. This theory proposes that our three-dimensional universe, with all its depth and complexity, is actually a projection of information stored on a distant, two-dimensional surface.
Imagine a hologram, a flat piece of film that, when illuminated properly, can project a three-dimensional image. The holographic principle suggests that the universe operates in a similar way.
The information content of a region of space, according to this theory, is encoded not within the volume of that space itself, but on its boundary, a distant surface that surrounds us like a cosmic horizon.
This might sound utterly preposterous, but there's a surprising amount of theoretical physics backing up this mind-bending idea. It stems from the study of black holes, those enigmatic objects whose gravity is so intense that not even light can escape their grasp.
Physicists discovered that the information about everything that falls into a black hole doesn't disappear, but is instead encoded on its event horizon, the point of no return. This led to the mind-blowing realization that the three-dimensional information about the black hole's interior could be entirely represented on a two-dimensional surface.
Some physicists believe that our universe itself might be a hologram projected from information encoded on a vast distant surface that surrounds us.
This holographic screen wouldn't be a physical object like a movie screen, but rather a boundary of space-time, perhaps even the edge of the observable universe itself.
The holographic principle challenges our very notion of dimensionality, suggesting that our perception of the universe as three-dimensional might be an illusion. Imagine a vast, invisible current flowing through the cosmos, dragging entire clusters of galaxies along with it like driftwood on a cosmic river. This is the enigmatic phenomenon known as dark flow, a mysterious force that defies explanation within our current understanding of the universe.
In the standard model of cosmology, the universe is thought to be expanding uniformly in all directions, the after effect of the Big Bang. However, observations of galaxy clusters have revealed something peculiar. They seem to be moving at an unusually high velocity towards a specific region in the sky.
This motion, dubbed dark flow, cannot be explained by the gravitational pull of any known matter or energy in the observable universe. It's as if some invisible hand is reaching out from beyond the cosmic horizon, tugging these galaxy clusters towards an unknown destination.
The implications of dark flow are profound. It suggests that there might be structures, perhaps even other universes, lurking beyond the observable universe, exerting their gravitational influence on our own cosmic neighborhood.
Imagine vast concentrations of matter and energy, remnants of the Big Bang, or perhaps even other universes pulling on our own like cosmic magnets. These structures would be invisible to our telescopes, shrouded by the vast distances of the universe, but their gravitational influence would be undeniable. The mystery of dark flow remains unsolved, a tantalizing clue pointing to the vastness and strangeness of the cosmos. Prepare to confront a truly unsettling idea, one that delves into the very nature of consciousness and the possibility of existence arising from nothingness. This is the chilling concept of Boltzmann Brains.
Imagine a universe devoid of stars, planets, and life as we know it. Just a vast, empty void, governed by the laws of physics and the relentless march of entropy. Now imagine that within this void, due to random quantum fluctuations, a fully formed, conscious brain spontaneously pops into existence.
This, in essence, is the idea behind Boltzmann Brains, named after the 19th century physicist Ludwig Boltzmann, who explored the statistical nature of the universe.
The theory suggests that given enough time and a sufficiently large universe, even the most improbable events, like the spontaneous assembly of a conscious brain from random particles, become not only possible, but inevitable.
Think about it, our brains, the seat of our consciousness, are incredibly complex structures, composed of billions of neurons firing in intricate patterns. To think that such a structure could arise spontaneously from random fluctuations in a void seems absurd.
However, the laws of physics do allow for such occurrences, albeit on extraordinarily long timescales. Given an infinite amount of time, any configuration of matter, no matter how improbable, becomes possible.
The concept of Boltzmann Brains is a thought experiment that pushes the boundaries of our understanding of consciousness, probability, and the very nature of existence. These theories may sound like science fiction, but they are grounded in real scientific inquiry. From the mind-boggling possibility of infinite versions of ourselves to the unsettling idea of our reality being nothing more than a simulation, these theories remind us that the universe is far stranger and more wondrous than we can possibly imagine. Don't forget to like, subscribe, and hit the bell icon for more mind-blowing content.